So here we have if xyg belongs to R plus and x multiplied by y multiplied by z equals to 1, then we have to prove this inequality. On the left side we have three different terms multiplied, and each of these terms has three values which are x to the power of 3, y and y here, y to the power of 3, z and z here, z to the power of 3, x and x here. In order to use this equation x, y, z equals to 1, the powers of x, y and z must be same, so that we can use x multiplied by y multiplied by z to the power of n equals to 1 to the power of n equals to 1. Here we can see that when we multiply all these values, we will get the same power of x, y and z, which is x to the power of, we have 3 here, plus we have 1 and 1 here, 1 plus 1, which is equals to x to the power of 5. Similarly, we have y to the power of 3 plus 1 plus 1, which is equals to y to the power of 5, and also z to the power of 5. Hence, we have to use the AMGM inequality for each of these three terms and then multiply to get this inequality. For the first term, we have the arithmetic mean is greater than or equal to the geometric mean, which gives x to the power of 3 plus y is greater than or equal to 3 multiplied by cube root of x to the power of 3 multiplied by y, which is equals to x to the power of 3 plus 2y is greater than or equal to 3 multiplied by the cube root of x to the power of 3 multiplied by y square. This is our first equation. For the second term, we have y to the power of 3 plus 2z is greater than or equal to 3 multiplied by the cube root of y to the power of 3 multiplied by z square. This is our second equation. For the third term, we have z to the power of 3 plus 2x is greater than or equal to 3 multiplied by the cube root of z cube multiplied by x square, which is our third equation. Multiplying these three equations gives x to the power of 3 plus 2y multiplied by y to the power of 3 plus 2z multiplied by z to the power of 3 plus 2x is greater than or equal to, we have 3 times 3 here, which is equals to 3 to the power of 3 multiplied by cube root of x cube y square in the first equation multiplied by y cube z square in the second equation multiplied by, we have z cube x square in the third equation. This is greater than or equals to 3 to the power of 3 is 27 multiplied by cube root of x to the power of 5 multiplied by y to the power of 5 multiplied by z to the power of 5, which is greater than or equals to 27 multiplied by the cube root of xyz to the power of 5, which is greater than or equals to 27 multiplied by cube root of 1 to the power of 5, which is 1, which is greater than or equals to 27. Hence, we have x cube plus 2y multiplied by y cube plus 2z multiplied by z cube plus 2x is greater than or equals to 27, and proved.